Welcome to Rges Pre-Algebra. This is Lesson 18B. We're going to cover sections 4.9 through 4.10, and this is regarding multiplying and dividing monomials. So first off, what is a monomial? Recall that if I have an expression like this, 7x plus 2, y minus 19, I have a trinomial. These are each a term. Terms are divided by addition and subtraction. So we have three terms here. I could include the subtraction sign there or not, depending on how I want to look at it. But this is a three terms, and so this is a trinomial. But if I have an expression without any addition and subtraction in it, or that addition and subtraction is within parentheses that are being multiplied and divided, then that is a single term or a monomial. One term equals a monomial. So let's say I have 2x times 5xy squared. This is being multiplied together, and so this is a monomial, even though it looks complicated. Just 2a, or just a, is also a monomial. Any of these are monomials. Okay, so I want to multiply. This is multiplying, in fact. It is monomial when you're finished, but it's multiplying two monomials. There's the first one, there's the second one. Okay. So this is what the kind of problem we're looking at. Now, I actually gave you a hint and talked about this last time in class. Let's just recall, first off, what do we do with exponents when we're multiplying a variable? So if I have x squared times x to the fifth, this was the basic idea, we add exponents. And you can refer again to last tape to remember why. But we have x times x times x times x times x times x times x. 7 x's being multiplied together. So we add exponents, and my answer is x to the 7th. Well, we're just going to use that basic idea with the idea that we could have numbers and different kinds of variables. There's one term being multiplied by another term here, so we're multiplying two monomials. Our answer will also be a monomial in this case. And what have we got? We're going to multiply first the numbers. 4 times 2 is 8. Then the x's. To multiply x's, we're going to add exponents. 1 plus 2 is 3. And to multiply y's, we're going to add exponents. And this is my answer. Rather straightforward, simpler than a lot of the ideas that we've had to learn here. So let's give you another example. Again, we have a monomial here times a monomial there. This parentheses next to each other means that I'm multiplying, and so I'm going to do what I just did the last time. First, I'll look at numbers. 3 times 2 is 6. Then I'll look at a's. I'm multiplying a variable together, a single variable, like an a, a b, an x. So I'm looking at all the ones that are like, that are the same, and I'm going to add exponents. 2 plus 1 more is 8 to the third. I'm looking at the next variable, b. I only have it one time here, so I'll just copy it down. Nothing else to do with it. And my next variable is c. And I don't have any others, so I'll just copy it down. Okay, my last example here is I have 1, 2, 3 terms. They're all monomials. This is a monomial. The second term's a monomial. The third term's a monomial. And they're being multiplied together. So I'm multiplying monomials. So let's multiply our numbers. 2 times 3 is 6. 6 times 5 is 30. Look at my first variable, an x. I'm going to add exponents. That's 1 plus 2 more plus 1 more. That's x to the 4th. I'm looking at my y variable. I'm going to add exponents. 2 plus 2 more plus 1 more. That's x to the 5th. And that really is as easy as it gets. So all of your problems that you're being asked to do, it says prove each answer by writing it out in long form in the first group. I don't need you to write it out. Just go ahead and give me the answer, because I don't think that this is complicated enough to require writing out in steps. So hopefully that's true. Now let me look at anything else assigned in this section. So you were assigned also the sharpening skills 1 through 25 all. Now that's first section 1 through 9 is simply what you've been learning in the last 2 classes. So that's just a little more practice. When we get to something like 10, 11, or 12, let's look at 10 together. I'm not going to do the whole problem, but we'll get you started. Remind you, if we had 8x squared plus y, and I'm told to evaluate it. They give me a value for x, they give me a value for y. So I would plug those in. My value for x is 4, so that would be 4 squared. My value for y is 1/2. Now remember order of operations. Do what's in parentheses first. Powers, multiplication and division from left to right, and addition and subtraction from left to right. So I'm not going to figure out the answer for you, but I am going to remind you of the steps. First, I would square the 4. 4 squared, 4 times 4. Then I would add 1/2, and then I would convert it to an improper so that I can multiply. When I get ready to multiply, canceling is a wonderful thing. So cancel first and then multiply what's left. So you should be able to get the answer to those 3 by following the steps you've already learned. Simplifying polynomials, 13 through 18. What is the big rule for simplifying polynomials? A polynomial would be where I have a lot of terms I'm adding and subtracting. And recall, for 13 through 18, you can only add or subtract like terms. That means they have to have the same variables to the same powers. So you should be able to recall that quickly. 19 through 22, addition and subtraction, going back to the first chapter. Be careful when you get to the fractions that you are going to leave me in their most simplified form. In other words, if you end up with 2 and 19/3, let's say, I have to convert this 19/3 to a mixed. In that case, it would have be 6. That would be 18 and 1 more third, and then I would add that to the whole number. Okay. So that's just a reminder. And then the last thing to remind you of is 23 through 25 are all going to do with proportions set up for percents. So 17% means 17 over 100 is what? 17% of 86 would be converted to a problem that says 17 over 100 equals what over 86? Recall that? So I would cross multiply. I'd get 100x equals 17 times 86, and then divide to solve for x. The next one says 5 is what percent? I don't know what the percent is, so I put x over 100 equals the smaller part or the first part. You have to identify what's a part of what by the question. 5 is what percent of 200. So the 200 is the bigger part and the 5 is the part. Now this number up here could be larger. In other words, if I had over 100%. But in each case, you have to always identify how these two numbers are related to one another, which goes in the numerator and which in the denominator. And the word of is a good clue, because my of is going to be in my denominator. Okay, and this, for this side, the clue is percent. Okay, So hopefully you recall that. We spent quite a bit of time. Again, cross multiply, you get 200x. 200 times x is equal to 100 times 5, and then solve. And finally, for the next one, it says 25 is 40% of what? So our 40 is with percent, so that's always over 100. And it says of what? So my variable is going to be down there with the of in the denominator, and 25 would be in the numerator. Cross multiply, you get 40x equals 100 times 25, and then solve it. Now let's go on then in the next section to talk a little bit about 4.10. Now again, I briefly showed you this in class on Monday. Recall that if we're just having variables, if we had x to the 7th over x squared, let's say, when I'm dividing, I subtract exponents, and the big key is to remember, is it going to go, my answer going to go in the numerator or the denominator? The answer always goes with the larger one. So this is the larger, the numerator, so 7 minus 2 is 5, and it's placed in the numerator. If instead I had x squared over x to the 7th, I'm going to do it the same way. I'm going to take 7 minus 2, but I start with the larger exponent. It's x to the 5th, but the larger is in the denominator, and so put your answer in the denominator, just like that. To prove it to yourself, go ahead and write it out. Write out 7 x's on the numerator, 2 in the denominator, cancel, and you'll see you get 5 in the numerator when you're done. Or in the second example, write out 2 in the numerator, 7 in the denominator, cancel out, and you get 5 left in the denominator. Okay? Now, all we're doing here, just like we expanded this concept in the last section, is we're going to just combine several variables and numbers. In the first example, sorry, let me get this back here. I'm going to say 16x to the 3rd divided by 4x. Do it methodically, just like we did in multiplying. First, look at numbers. 16 divided by 4 is 4. Is that going to be in the numerator or the denominator? My larger value's in the numerator, so I'll put the 4 up there. 3 minus 1 is x squared. Again, the largest is in the numerator, and that's my answer. Giving you another example. Looking at my numbers first, 18 divided by 3 is 6. Put it in the numerator, because that had the largest value. My A's, 2 minus 1 is 1. Put it in the numerator. My B's, 2 minus 1 is 1, but it's in the denominator. And my C's, 2 minus 1 is 1, but that's in the numerator. Just like that. Okay, you're going to be asked to, let's take a look here at the assignment. Okay, you're going to be doing 1 through 17 odd in 4.10, and then for the sharpening skills, I want you to do the 4 word problems. Let's look at those real quick. 25 says, Avery Parker bought a dozen eggs at a store for $3.65. She bought the same size eggs the next week at the same store for $2.92. What was the percent of decrease? Okay, so let's recall, percent of decrease means you take the first price minus the second price, so you're getting the amount of decrease, and you put that answer, the amount of decrease found by subtracting, and you put that over the original price, and that will give, and then of course do the arithmetic, and that will give you the answer. Okay, let's see. The second problem. So if you have a certain amount, 1 3/4 teaspoons of sugar to make 1 cup of hot chocolate, it's asking you how many teaspoons of sugar should he use to make 10 cups. So what would I have to do? Well, to change from here to here, I have to multiply by 10. So here I would multiply by 10. How would I do that? There's 2 ways. You could either take this fraction, convert it to an improper, multiply, and convert it back to a mixed, or you could multiply the whole part and the decimal part, actually, or the fraction part. Actually, I think the first way is the way I've been teaching you all along. So convert that to 4 times 1 is 4 plus 3 more, that's 7/4. Multiply it by 10, okay, which of course will be multiplying into the numerator, and then convert it back to a mixed. Let's look at 27 for a minute. Percent of increase is the same as percent of decrease. You find the difference between the 2 amounts, and then you divide it by the original. Okay. (28). Okay, we have a man, he's 6 feet tall. He casts a shadow of 9 feet. A building casts a shadow of 36 feet. How tall is the building? So this is the how tall the object is, and this is the shadow. This is very similar to the hot chocolate example. To get from 9 to 36, I multiply by 4. So over here, you would have to multiply by 4. Okay, we'll see you soon.